Third presenter is the Salomé Iglesia. The title is Services for Traffic Management Systems. Salomé, can you present yourself, introduce yourself first, please?
Hi, can you hear me?
Yes, we can.
Okay, thank you. Thank you for the introduction. Thank you also for giving me this opportunity to share with you some information about our maintenance portfolio within Siemens. My name is Salomé Iglesia. I'm responsible for head of product management and responsible for our portfolio here in Siemens Mobility Switzerland. I'll start with my presentation. Good. Then first, the main focus that we have within Siemens, and that's also the main focus of our customers, is with these maintenance solutions, what we are aiming to achieve is to minimize disruptions of the rail operation. That's something that we can do by means of preventing or anticipating the incidents or minimizing the time to repair. And I think that is the core of the core of the design of these solutions. We are well aware we are investing a lot of effort on these solutions to anticipate the incidents, but there will be still a remaining 20 to 30% of the cases where we would have actually disruptions on the network, on the operation. And therefore, we also want to bring solutions to minimize the time to repair by offering the maintenance staff the means that they need to resolve and to restore the operation as soon as possible. That's to our credo. And I would like to share with you 5 of the maintenance solutions which we have in the field of railway infrastructure, more specifically in the field of traffic management systems. And I would give you some short information about some of them, but I would like to show you a demo on the Trek Ops Intelligence Assistant, which is the one I'm going to be presenting the last. So then, as I mentioned, we have different options. We have solutions for preventive maintenance, we have solutions for predictive maintenance, and we have solutions for corrective maintenance. I would start with our solution, Business Intelligence Solution, ILTIS BI. And as the claim says, the key focus of this one is to analyze the past with this business intelligence solution to gain important insights for the future. And what we are doing here is based on the information available on the system, within the system, we can perform retrospective analysis of the performance of the system. And by doing so, we can identify those spots where we have misperformances, so we can take decisions to improve that. We can, through preventive maintenance activities, we can improve the performance of both the infrastructure, but also of the organization as such. That's the main goal of this solution, which we have in place. Then the next one would be the network management system, which is the other side. What we're doing is real-time information compared to the previous one, which was a retrospective analysis of whatever happened in the organization. Here we have real-time information of, in this case, of the hardware performance, of the network performance of our installations. And what we do here is we set the values which describe the system when it's performing in the normal range, so to say, to be able to identify the deviations, the trends which would be leading eventually, if we don't do anything, to a disruption of the system, of the performance. And that's something that we can achieve by means of this solution. So again, it's the other way. What we're doing here is predictive maintenance to anticipate the incidents. And then the other three, what we have is, so these other three solutions are more based on corrective maintenance, on how to improve, how to minimize the time to repair. The first one is there are the ILTIS web services. And here, it might not see that spectacular to have information, lifetime information in the cloud and being accessible from any mobile device, any web accessible device. But that is the case for safety relevant infrastructure. It's not that common, it's not that simple to get information on real time outside this closed network to be provided to the users. And that's what we're doing here. And as the claim says, we have the operating situation always in view, anytime and everywhere. That's the added value of this solution. Then next one is our Simon solution. And actually, what we're doing with Simon is we're offering an overlay, a monitoring overlay. For our customers, we might be providing some of the systems that they have in place, but we might well not be providing all of them. But still, for our customers, for the maintenance organization, they have to take care of all of the systems. So what we're bringing here is we're gathering all information. We're providing with an overlay, monitoring overlay, to be able to monitorize all of this system of systems. So we have a holistic monitoring approach in order to optimize the way maintenance is being done, in order to optimize the maintenance organization, the way they perform their activities, the way they manage their resources. And that's what we do with Simon. And as you can see here again is this safety relevancy, which means that it's really relevant to ensure through security measures that the safety of the core system is not being jeopardized by the fact that we are sending this information to the outside world, so to say, and that we are processing and making this information available for web devices. Here's some short description of the highlights that we offer with this overlay, with this monitoring overlay. First is monitoring, of course, of the whole infrastructure, not just some parts of it, but the whole infrastructure, from interlocking to power supply to telecom to traffic management system and so on. And also quite interesting is that you are able to prioritize, to give a priority to the different messages, to different failure messages that you would get. That means you can ensure that if in any case the critical assets are going to be treated with priority whenever an incident would happen on them. And that again improves the efficiency of the maintenance organization to solve the problem of those critical assets. Important as well is, as is it an overlay, you can actually navigate through the different diagnostic systems, and you can as well not just visualize the state, but in case you would have an incident, you can travel, you can navigate to the system itself, and eventually, if that's supported by the system, by the field element, you can remotely support and actuate on this solution. That's something that is quite valuable, for instance, to reset a field element whenever there's a failure and so on. Again, here is the safety criticality relevant, and that implies that the security expectation and requirements are really high. Another interesting aspect, again, to improve, to minimize the time to repair, is you can define for those standard interventions, you can, as it's possible, to define recommended actions based on previous experiences, and reporting and documentation is also a possibility, as we would have the information being located in a cloud, and we can process this information. That's an overview for this overlay, monitoring overlay of the whole infrastructure for our customers. And then I would go to the solution that I wanted to, that I would be afterwards showing a short demo on, this, what we call the TrackOps Intelligent Assistant. And you can see here is a feature, is an additional feature to Simon. And what we're doing here is, with Simon, as I mentioned before, we are interconnecting, we are gathering all the information coming from these different systems. And we have additional information. We have the signaling plans, the infrastructure, the static information about how the system it's been built. We will have as well documentation on the systems, on the field elements, be it technical descriptions, be it maintenance manuals, and so on. And what we have is the additional, the add-on of this intelligent assistant is, we want to have not just the operational state at all time available, information available, but also we want to have the railway infrastructure available. That's something which is already possible at the moment, but it's a costly feature. And what we wanted to achieve is inexpensive approach. The goal is not to have an extremely accurate description of the railway infrastructure, but it has to be accurate enough, and it has to be updated on daily basis without being a costly feature. And that's what you can see here. We have something image capturing device mounted on the cockpit of the train. We have a fully automated process sending this information together with the position information to the cloud. We have artificial intelligence algorithms processing this information and making the correlation between the signaling plans and the information of the elements being identified in the images and the GPS, the positioning information. And that's being processed, and we're making this information available on the front end. That goes also for Simon. And then system architecture, it's something that I really like. It's really simple. What we bring is a really simple and inexpensive solution to give a basis data, to provide with a basis data, which we can use for quite a few different use cases. You can see we have data recorder. In the first stage, it was just a Garmin action camera, which we place on the cockpit of the train, and which is capturing the information on a certain interval. We have on the tracks the objects to be identified, signals, valises, and so on. We have the positioning system, GNSS. We have the backend processing where these algorithms are being run and the correlation is taking place, and we have the front end. That's quite straightforward system architecture. And here I wanted to show you the evolution. This was the first, the proof of concept that we ran was really a quick and simple approach for that. Then the second stage, which is actually what we have at the moment running, was a collaboration together with the ETH, and it's more sophisticated. It's also with this second option, we have a fully automated capturing of information. The camera is just when the train stop, then the camera stops taking picture, and the same applies when the train starts moving. The system starts capturing images and sending that to the cloud. And then the next step, what we are actually triggering and what we are starting to work on, is to develop an app. So we would use the camera of the integrated camera of a smartphone as the capturing device. So that would be as an overview, and now I would like to show you the demonstration to this one. So that would be the outcome of this data, which is being captured daily during several long period of time. The idea of that's these slides, this information that this demo that I'm showing now, it was done with the first setup. But still, you can see the quality of the image is really good. If you could navigate through that, so you would see the different elements which are being identified all along the way. Also, in terms of data protection, we had to ensure that both vehicles and people standing around would not be able to be identified, and that's why this information is being pixelated. So that's pretty much it. What we achieve is by means of installing a camera on a train, which is going to be traveling this path. In any case, we are able to capture every day continuously this information in a really simple and with no minor activities involved. And I would like to show you some use cases. What can we do with this information that we have? The three use cases that I'm going to be explaining to you are just like the low-hanging fruits. Of course, there are many more other use cases which we are under discussion with our customers and which we would be developing in the near future. The first one would be I'm maintenance responsible. I get an alarm from Simon, and it's telling me you have an incident on a certain signal. For instance, it's going to be QUB main signal F. So then I would have a look at that. I would search for this signal in my HMI, and then I would get instant information about the reality, the real infrastructure situation. First, I would say, okay, is this kind of signal? So I would automatically know the equipment that I need and the things that I have to take into account to go to the signal to repair the incident. Also, I can see that it's easy to access to this part. It's easy to park the car and easy to access without having to walk through the tracks for a longer distance. Of course, experienced maintainers, they would probably know exactly where the signal is being placed, but we might not always have the experienced maintainers on the line. We might have someone new coming and being responsible for this part of the track. So it's really valuable to be able quickly with a click to get instant information of the rail infrastructure being affected by this incident. Additionally, I have here some information, GPS position, and also data sheets, which I would be able to, which the operator would be able to decide which information I want to make available for my maintenance staff. That could be a system description or maintenance manuals. Now I know where my signal is. I know what I need to know to go and repair, and then I could use. That's also quite important for us. We want to reuse from Siemens. We want to reuse the existing solutions, the existing technologies. And for instance, Google Map can navigate you better than any way to a place. So what we did is we integrated a link to Google Maps. So we can say, okay, I want to get there, and the shortest way is important for me. So, okay, now I'm gonna go this way, and I'm gonna send this direction to my phone. So it's been linked automatically, part of the solution. That would be one use case. For maintenance, for corrective maintenance activities, is a great support for that. The second use case would be, we have for training purposes, be it for train drivers or for maintenance staff. By means of this solution, you can navigate through the path. You can identify which are the relevant spots. Now, exactly, we're traveling again, and you can travel through the tracks without having to travel through the tracks. Actually, there might be some delay on the system. Okay, so that's a quite easy to quite straightforward case as for training purposes for both train drivers or maintenance staff. And then the third one, which I find is a quite interesting one, maybe for those not this much involved with track maintenance, which is weed detection. You can see here, for instance, these spots. You might see that there are a lot of weed growing on the tracks. And this is quite critical, not because if it doesn't look clean or nice, but because it actually brings major problems in terms of stability of the tracks. And that can lead to incidents, that can lead to accidents. And also this weed growing within the tracks could eventually damage the onboard system installed on the lower part of the trains. So that is important. That's really important for the operators to have that under control. But it's not easy to plan, and it's not easy to plan that in an efficient manner. And what we can do with information which we have available is to learn our algorithm, to recognize and bring alarms to whenever this weed is growing up to a certain level. And again, that's one, you don't need an extremely accurate system to identify whatever is on your images, but you need that to be happening on daily basis, so you can quickly identify when you have that. And that's what we are offering with this solution. Then going back to the presentation, that would be it for the demo part. Then just as summing up, and that would be the last slide that I will be presenting today, summing up what we have seen on this intelligent assistant feature. This is an add-on solution, is an add-on feature to Simon. That's Siemens. Okay. There's an add-on feature to Simon, our overlay infrastructure monitoring solution. It's based on inexpensive resources. We have standard cameras being installed, we have mobiles, we have cloud, and it's fully automatic. And by both aspects, we can ensure that we have a cost-effective solution for daily updates on railway infrastructure, on the states of the rail infrastructure. For the, just to give a hint, for the proof of concept, we were taking the data, the capturing time was approximately 18 hours, and we have like approximately 150,000 pictures a day. It's based on machine learning application, again, to have this fully automated process, and is the basis data for many different use cases. It's not raw data because it's been previously processed based on signaling plans, but we have this smart data available for quite a few different use cases, which we are discussing with our customers at the moment. The next steps, as I mentioned, first, regarding the capturing device, we want to replace the fixed camera that we have at the moment by an app, an integrated camera on a mobile phone, a smartphone. Second is to finalize the proof of concept on weed detection. That is from the information that we have, just to have the processing, to get from the information which we have available to the alarming system to bring attention to those spots which we need to intervene. And the last one is we are participating, Siemens is participating in Hackathon Zurich 2020, and we're bringing a challenge which is called Lift the Veil. And what it's about is we are not going to have always sunny days when we capture the images. And what we're trying to do here is by means of artificial intelligence to be able to improve the visibility for those days where the sun is not shining and we have rain. And that would be it from my side. Thank you for your attention. And I don't know if we have time now for the questions, or otherwise more than happy to answer them in the session.
Yes, thank you. We are going to leave the questions for the
Okay.
for the end of the session.